Right, question, this is IEB 2022 stats final paper, question 3.2. It says a random sample of 80 people from a political party were asked whether they were planning to vote in the next election. People said they were ready to vote. So in other words, the proportion in the sample who are intending to vote is equal to K over 80. Remember the notation that we use, P hat is a proportion of the sample and P is the actual population proportion. So K over 80 said that they were planning to vote. Then in an alpha % confidence interval, for the population, for the actual population proportion P, who were planning to vote for this party was 0.468, between 0.468 and 0.682. So this study showed that an alpha % confidence interval led to a lower boundary where 46.8% said they were going to vote, and an upper boundary where 68.2% of this particular party people said they were going to vote. So remember that the sample, these are your upper boundaries for P, your lower boundary for P, and your upper boundary for P, the actual population proportion. And your sample proportion will always be smack bang in the middle of that. So the sample proportion for this particular thing is going to be 0.468 plus 0.682 divided by 2. So your sample proportion P hat is 0.575. But we were told that for that same sample proportion, the sample proportion was K over 80. So K over 80 must be equal to 0.575 times both sides by 80, and you end up with K is equal to 46. In other words, this figure of 0.575 is 46 over 80, which is the sample population proportion, as opposed, and these are the upper and the lower boundaries for the population proportion based on that particular sample. So based on the sample, we get upper and lower boundaries for proportion. Right, so then, now in the next question B, it says, hence find the values of alpha. In other words, you got to go find your confidence interval to the nearest percentage. Now, in order to find a confidence interval, we need to go find, so the boundary, the z-score for the boundaries, one of the boundaries. So we know that the lower boundary is 46.8%, and the upper boundary for the study for the population proportion is 68.2%. So I need to go find the z-score that goes with 0.682. I don't know that yet. So I need to go find the z-score. So to find the z-score, so to find the confidence interval, you need to critical z-score for that confidence interval. And so we're going to use our formula, which we rewrite like this. It's on your formula sheet, except we add the p hat into the formula. So your population upper parameter, your top boundary, is equal to p hat plus your z-score. If it is your lower boundary, to be p hat minus your z-score, p hat 1 minus p hat over n. Well, for the top boundary for the study of the population proportion is 0.682. P hat, our sample proportion is 0.575 plus z p hat 1 minus p hat over n. So if I go and minus 0.682 minus 0.575 divided by this whole thing, I end up with a z-score for the top boundary, this confidence interval, I end up with a z-score of 1.94. So my z-score that goes with 0.682, the top boundary is 1.94. So then this area over here on our diagram represents h of 1.94. So I'll go to my table and I'm going to look up h of 1.94. And if you go to your table and you look up h of 1.94, you see that this area over here is 0.4738. So that area here is 0.4738. But we want our confidence interval, which is between both of these boundaries, So our confidence interval is going to be that times 2, but then to get to a percentage, I times it by 100, and that'll give us that whole confidence interval over there, and I end up with a confidence interval of 95%. All right, okay, so that's your solution for B. Remember, this whole thing is you've got a sample population, okay, proportion, okay, based on that sample population proportion, and N, the size of the sample and the standard deviation of the population, and we get an upper and a lower boundary for where we can say with a certain degree of confidence the population proportion lies within. Right. Question C, and it's badly phrased because in my opinion, I missed that sentence between B and C on your question paper. I think it should be with question C. It says it is known that 59.3% of the population of ABC voted in the last election. Okay. If we assume that everyone who planned to vote did vote, is there evidence to say that the proportion of people from ABC who voted has changed? Give a reason for your answer. Right. So for this whole study, okay, for a 95% confidence interval, the upper boundary over here was 68.2%. So we can be, if the mean is 57.5, population is 57.5, we can be 95% confidence, okay, that if it's below 68.2%, it's within normal parameters. But for this election, 59.3% voted. Well, 59.3% as a proportion is about over here. Okay, so there is 0.593. And as you can see, it's well within, it doesn't fall within the significance level where we can reject things. So it falls within the confidence interval and not into this region of rejection, which would be to the right of 68.2. Okay, so just showing the link between confidence intervals and significance levels. Okay, so it's within the confidence interval, 59.3%. So there's no significant change. Okay, and yeah, so nothing really has changed. Okay, okie dokie, guys. Hope that makes sense.